we'll find the Fourier series representation of the signal x of t is equal to sine of omega naught t. So let's find the Fourier series representation of x of omega naught t. X of t is equal to sine of omega naught t. And to solve this, we need to make use of both the equations. So we know that there are two equations for Fourier signals, and the first one is summation k from minus infinity to plus infinity x of k e raised to j k omega naught t, where omega naught is the fundamental frequency of the signal. So we need to make use of this equation in solving the trigonometric kind of problems. Now, in order to solve this, we need to get this term as we saw in the DTFS. We need to get it to the form e raised to whatever the value. So we can expand this sine omega naught t. So it can be expanded as e raised to j omega naught t, e raised to j omega naught t minus e raised to minus j omega naught t divided by 2j. So we know it is the expansion of sine of omega naught t. Now we go for rearranging these terms. So we can write this term as the first term as 1 by 2j, and this e raised to j. Let's write e raised to j. To get it to the form e raised to j k omega naught t. So let's get this one. Let's write this one as 1, then omega naught t. If I write in this way, there is no change in between this term and this. And similarly, the second one becomes 1 divided by 2j. This would be written as e raised to now j. We need to write always the positive power, so let's take this as minus 1. We can write in this fashion. And as it is the standard signal, we don't have to compare. Sine of omega naught t itself is given. Now we have written the signal expansion in this fashion. Now we can compare this x of t. Now this is also x of t is equal to. So this x of t is equal to is given to us. X of t is equal to this much, and x of t is equal to, it is this equation. By comparing this one, we can find that now this equation is same as that of this, wherein the value of k will be, it is same as this equation, wherein the values of k would be, now k is 1 and minus 1, means it is x of t itself, but it is existing for the values of k. So for k is equal to the same expansion. If I write k is equal to 1, then, and if k is equal to minus 1, if k is taking these two values, then this expansion of the term becomes simply, it would be it is, so from minus infinity to minus 1, that is less than minus 1, there is nothing. So k is just minus 1 first. So there's x of minus 1 e raised to j, k would be minus 1 omega naught t. This no, omega naught t. And when k is 1, we can write this one as x of 1 e raised to j 1, we can write k is 1 means omega naught t. when we compare these equations, we conclude that the value of x of minus 1, the value of x of minus 1 is, x of minus 1 is 1 by 2j. X of minus 1, it is minus, so this term is this one, it is minus 1 by 2j. And here it is j, 1 it is, and here 1. The value of x of 1 is, it is just plus 1 by 2j. We can write this one first and this one later also. Now from this we got to know that the Fourier, now x of k is the Fourier representation. So we got x of minus 1 and x of 1. These are nothing but the Fourier domain values of our signal. And in the Fourier domain, we need to write the magnitude as well as the phasal values and even the plots of that. So the magnitude of this one, the magnitude of this. So if I write what is the magnitude of this x of minus 1, we know how to find the magnitude. The magnitude of x of minus 1 is, it is magnitude of 1 by minus of 1 by 2j. So just we can apply, if it is x plus jy, we know how to find its magnitude. It is x square plus y square. It is x square plus, here the real term is 0 and imaginary term is like just 0 minus 1 by 2j. So the magnitude of this one is root of 1 by 2 the whole square. So which is nothing but 1 by 2. So j will not come here. Similarly, the magnitude of x of 1, the magnitude of x of 1 is again same 0 plus 1 by 2j. If it is 0 plus 1 by 2j, the magnitude of this one is root of 1 by 2 the square, which will be again 1 by 2. So the magnitude of x of minus 1 as well as x of 1 is 1 by 2. So we need to plot the magnitudal plot. So let's plot in this way. It is our magnitudal plot. The axis would be k, and let's represent 0, and magnitudal plot is represented in this way. It is magnitude of x of k. Now k can take different values like plus 1s on this side. Now k is 1 here. Let's make it a bit bigger. So k is 1, 2 and so on. And here it would be minus 1, minus 2 and so on, minus 3 and so on. Now when x is like x of minus 1 we have, so k value is minus 1, means at minus 1 its value is what? 1 by 2. Let's say this is 1 by 2 value, so we represent usually in this dot way and this. And similarly at x of 1 its value is 1 by 2, so we represent. The magnitude of this one is 1 by 2. So magnitudal plot. So this magnitudal plot, the property of this magnitudal plot is it is always symmetrical about the vertical axis. So when we fold it, or it is always an even signal. Let's go for, then this is our magnitudal plot. For none other value of k, we have non-zero value of this magnitude of x of k, so this will be our magnitudal plot. Then let's go for the phasal plot. Phasal plot is represented in this way. So angle of, in this way we write angle of x of k. the angle of x of k graph. Now let's take the different values. Now angle of x of minus 1. Let's say we talk about x of minus 1. The x of minus 1's value is equal to, we have, now we need to talk about only, it is the angle of x of minus 1 can be written as tan inverse of, now for x plus jy, the theta is tan inverse of y by x. So it would be tan inverse of minus 1 by 2. Or we can find even in this way, x of minus 1 is equal to minus of 1 by 2j. So as it is minus of 1 by 2j, we know j contributes 90 degrees. J is contributing 90 degrees. So, so tan inverse of minus 1 by 2 divided by, now x is 0. We get tan of minus theta as minus tan theta. So minus of tan inverse of infinity it is. So minus of tan inverse of anything divided by 0 is infinity. So tan inverse of infinity is pi by, it is pi by 2. To find the magnitude, this j has to be like, it should be in the x plus j by, j has to be there in the numerator. And to get that one, let's multiply this one like individually, we need to multiply them. So this x of minus 1, this x of minus 1 will become, so x of minus 1 is minus of 1 by 2j. So it becomes minus 1 by 2j. J we have to take it at the top. So multiply and divide by j. When we do this, so we'll get minus 1 and this minus minus cancels. So plus 1 plus j by 2. And when we do it, it would be plus 1 by 2. And the angle corresponding to this one would be plus pi by 2. And similarly, the angle corresponding to x of 1 is, x of 1 would be, so let's take this term with the j at the top. So let's multiply and divide by j. When we do this, so this term would be minus j divided by 2. And the angle corresponding to this one would be minus pi by 2, because tan of minus theta is minus tan theta. So the angular graph corresponding to this problem would be in this way. What is angle of x of k, and even it has to be with respect to k as the axis. It represents 0. Then in terms of, it would be k is equal to 1, 2 and so on, minus 1, minus 2 and so on. So for k is equal to 1, the angle is minus pi by 2. So we represent this one, it is not amplitude, it represents the phase. Let's say this is 90 or pi by 2 value, and in the minus, when it is extended, let's say this represents minus pi by 2. Then the next value would be pi like this. So let's represent this one as minus of pi by 2 at k is equal to plus 1 and plus of pi by 2 at k is equal to minus 1. So this is our problem. Let's consider another problem. X of t is equal to cos of 4t plus sine of 8t. Now when this, our x of t is the sum of two signals. Here the omega naught 1 is equal to, omega naught 1 is equal to 4 and omega naught 2 is equal to 8. Omega naught 2 is 8. So whenever we have 2 or more than 2 signals are there, like if our resulting signal is the sum of 2 or more than 2 signals, then we have to take the individual omega naught ones, and then the fundamental period of this signal, the fundamental frequency of the signal omega naught, is always the GCD of these. So the GCD omega naught of this entire signal is GCD of omega naught 1 and omega naught 2. And we know that GCD of omega naught 1 and omega naught 2, that is 4 and 8. The greatest common divisor of 4 and 8 is of course 8. Is of course a 4. So our omega naught is equal to 4. So first we should do this, and then these kind of problems, whenever we have a trigonometric expression, we have to use that x of t formula. That x of t is equal to, let's write it, is equal to summation k from minus infinity to plus infinity x of k h of x of k e raised to j k e raised to j k omega naught t. So by using this we have to solve. So let's expand this. So by using the trigonometric form, the expansion of this cos is x of t can be written as x of t is equal to, now cosine is expressed as e raised to j 4t plus e raised to minus j 4t. The expansions of these two signals are these, and for the sine it is e raised to j a to t, e raised to minus j a to t. Now we have to rearrange these in what form? Let's see. Now e raised to j 4t, and we know that our fundamental frequency of this entire signal is omega naught. So it is e raised to j 4, means we can write e raised to j into 1, because we have to represent it in this form, e raised to j k. So let's say this k is 1. Then omega naught is 4. It's 4 divided by 2. Let's write it in this form. And similarly the second one becomes 1 by 2 e raised to, let's write it as j. Now let's write minus 1 plus the expansion of this term becomes, it is 1 by 2j e to the power j. This is 8, so it can be written as 2, because we have to write it in the form of fundamental period. So let's write it as e raised to j 2. Now omega naught is 4, so this overall represents e raised to j 8 only. And similarly minus of 1 by 2j divided by e raised to, now what would be the term? E raised to j, let's write minus 2 here, 4j. Now here clearly it's like k is equal to 1 and minus 1, and k is equal to 2 and minus 2. So when we write this, it is the summation, but k is for minus 1, k is minus 1 plus 1 and 2 and minus 2. So let it be the summation from k is equal to minus infinity to plus infinity. So these would be x of minus 1 e raised to j minus 140 plus x of 1 e raised to j1 40 and x of 2 in this way. So from this it's clear that x of 1's value is, the value of x of 1 is 1 by 2. The value of x of minus 1 is also 1 by 2, and the value of x of minus, now let's write x of 2, the value of x of 2 is equal to 1 by 2j, and similarly of x of minus 2, it is minus 1 by 2j. When we go for plotting the magnitude plot of this one, it looks in this way. It is the magnitudal plot, magnitude of x of k would be, now k is a 0, it's 1, 2, 3, and it's minus 1, minus 2, and so on. Now when k is equal to 0, its value is not there. When k is equal to 1, its value is 1 by 2. So let's represent. When it is minus 1 also, its value is 1 by 2. So we can represent. So when this is 2, its value is magnitude of 1 by 2j. We know it is again 1 by 2. So let's represent. Similarly, for minus 2 also, its value is 1 by 2. So these all are with magnitude 1 by 2. When we go for the phasal plot of this, so let's draw the phasal plot of this, which will be written in this way. So x of k is, for k is equal to 0, 1, 2, and so on, minus 1, minus 2, and so on. So purely the x of 1 and x of minus 1 are real, then the angle corresponding to them will not be like tan inverse of, if we go for finding the angle, it is tan inverse of y by x. Y is a 0 here, so 0 divided by 1 by 2 we are getting, so which is equal to 0. So only real terms are there, but x of 1 and x of minus 1, so there is no angle here. So with this we know that already, at if it is 1 by 2j, it gives us minus 1 by 2. So at x of 2, its value is minus pi by 2 from the previous problem. No need to calculate it again. And if it is minus 1 by 2, if it is minus 1 by 2j, then it is to be plus pi by 2. So these kind of problems, whatever it may be, like even though few more terms are there, one can calculate and plot the magnitude and phasal plots. Suppose if this problem is having a 1 here, like if it is 1 plus the any trigonometric value, then also its fundamental frequency will be same, the way of calculation is same. So we could write this one as 1 plus. We'll write this one as 1 plus. We know that 1 means it is e to the power j. We can write this one as e to the power of j. Now to contribute it as 1, it has to e to the power of j. It has to be e to the power 0. So e to the power j 0, e to the power j 0. Let's write it as 4t to make it a proper signal, and this signal will have its amplitude as 1. Its amplitude is 1 means we would have 1 in the magnitudal form. And as it is a real value, there is no imaginary part. The angular contribution is again x plus jy. If it is x is only existing, then tan inverse of y is a 0. So tan inverse of 0 is 0, no angular contribution. So these kind of problems one can try and solve. So we'll see the other kind of problems in the next video.